temperature different of both end and the middle, maybe go 50 based on our previously testing. Because in here, we have 3 different thermocouple insert here, here, and here. But with the length of this 60 cm reactor, we have a temperature constant
In the middle.
direction, yes. This one is based on our calibration. How we calibrate the temperature constant area for us to load the catalyst just in is when the reactor is new fabricate. This is a hollow tube, you have remember just now. We can insert the thermocouple from here into here. Then we stably remove tube from the most top until the end. They can find the area that has accuracy 1 degree. Then based on our calibration, the area constant is here. So no matter where you locate your catalyst, since you locate at this area, your temperature is constant from top until the end.
Okay.
So we have calibrated and we fixed the constant area size as here. So we let you to install your catalyst in the middle of the constant area. If you directly install the catalyst into the reactor, your catalyst will leaking because this is a hollow tube. You cannot mix your reactant gas only contact with your catalyst. It will be everywhere, maybe lost the connection, it will be decreased the mass transfer. So our design is to lock the catalyst only in the middle of the constant area. How to lock it? We need to make a filter that is can allow the gas to pass through but cannot allow the catalyst to pass through. This time we will search help from the coach rule, and the coach rule will be put in the middle of the one. We will use 2 gas distributors to lock the coach rule in the middle. Then only gas pass through, but no catalyst either leak from the bottom or escape from the top.
Like this is
Yeah. So we put our 2 gas distributor here, but you still need space. You need a space for you to load your catalyst. So the inside is distributed like this. Your catalyst locking here in the middle of the constant area.
Okay.
So when you install all the parts in sequence, holding to lock the constant area, the first 2 of the gas distributor to lock the catalyst, forbid to leak from the top to the bottom, holding for the gas distributor, catalyst. Now you can install your catalyst at this moment. Your catalyst, another gas distributor to forbid escape of the catalyst, holder.
So this one we have quartz wall
Yeah.
in between.
Every quartz rule must be installed in between.
In between.
Quartz rule. So your
Support by one.
yeah.
One.
So your sequence will be like this.
And the catalyst we just put here.
Your catalyst is put in here.
When
So how we install? We can do here. Hold the reactor. Hold the reactor. You can slightly give a little bit angle.
slanted,
Yeah.
okay.
And then you can slide in. Then slide in the first tube.
The first tube and the first
The
packet.
first pair of this, you can install either way you prefer. Install
Yeah.
and the tube. Now, catalyst.
Okay.
You can install your catalyst. The tube.
Can I put my catalyst?
You can put your catalyst in here. You want to put catalyst now?
Can?
Okay, then you need to put control properly. This demo I didn't put
Oh.
enough control. Or you want to do later yourself.
Later.
So you must install enough control.
Oh, okay.
How you specify the enough control? Wear gloves when you handle control because it's
Itchy.
Itchy, yeah. The latex gloves.
Mhm.
The
Glove.
cotton gloves is protect for heavy duty. It cannot protect your itching. But okay, I will wash my hand immediately. So you need to, you cannot cut the fiber, you're making the fiber.
Just press.
Yeah. You press it into the center. Lock it. Let some have outside, but you don't need to swap it. You just let it go in. Your catalyst in here. So your gas distributor will swap your catalyst into the center. Then you
The rest holding.
push in. Then it's okay. Oh, I forgot to install this one, so it becomes short. So you don't forget to install this one.
That one
in between.
pada catalyst pipe lah.
After you finish your catalyst install, you put this, then another two gas distributor. Then mark here. You don't need to searching for the which one is the screw. So you just follow the mark. For example, if you do this, you need to see, oh, where is the hole, right?
Yeah. So better marking.
It's already marked here.
Oh.
So you use the mark, use the available mark, then you can know the hole is just here. So the three parts must be installed all inside.
According the sequence.
According the sequence, we just simulate outside. By hand first. And use this one with less strength
To
to
tighten.
Open the furnace is the last step. But when you do, you lock the furnace is the first step.
Okay.
Lock the furnace is the first step. Then you will got the protection for the furnace not to moving. Then you don't lock the top at the beginning. Lock the bottom because the top is in the center. In the center. Even you rotate any angle,
Okay.
it's okay. But the bottom have a direction. So you must rotate to adjust here to be straight line as the cube. So you can see, you can adjust. You're feeling by your hand, a straight line. Then you can tie by your hand first. Tie by your hand first. Slow. Hold here.
Okay.
Don't let remove. Tie until you feel cannot move. And don't be too much. You can. I think for girls, this is we will never too much. So this one, when you lock the bottom, you can come to the top. Now you can lock the top. Still by hand first. By hand first. Then you can hold your reactor. Lock it. Okay. We finish the installation. During your reaction, you use methane and also hydrogen.
Yes.
Methane and hydrogen is flammable gas. So, and also the methane will lead to headache if you suck in too many. This has been reported by your seniors.
Okay.
Yeah, they reported, most of the reported is being in that lab because the gas exchange is not so properly. So when they are took long time into the meeting and they conduct a reaction
Headache.
for several hours, they got headache. So when you are doing your meeting, there's two ways to protect yourself. First is
Open the fan.
turn on this exhaust fan. Turn on the exhaust fan. Yeah, because both methane and hydrogen, the density is lower than the air. Lower than air, so they're going upper. Then we install the exhaust fan at the upper. So turn on the exhaust fan before you start it. You protect yourself. Another way is beside your operation or collect sample, you don't come into this room. You can observe outside. Because every one is controlled automatically, so you don't need to come after the reaction. You only come in for collect sample or adjust anything. Besides that, you don't need to stay here for observe it. You may take your headache or something.
Aircon better off or on?
Because you also need to come to collect sample, you have to enter. Previously, we also leave the gas. As you can see here, got the vent tube. We leave the vent tube out to the room. But I think after several years, the tube was decomposed because our condition is too tough. You can also install another tube here from the vent port, until it's to outside. You can measure from the tube. This tube is here. It's open now. Tube.
So now that the connection.
It's a cross-shape. So it's a pure tube. It's become cracking. So we can replace with a Teflon tube. Teflon tube will not decompose. So you just open this. You can do yourself. You open this, measure the Teflon tube, and lead it to outside. Beside you monitor the bubble or you collect sample, you can let the gas output right here. So this is the two-way protection. One is forbid to give out flammable gas inside the room. Second is enough exhaust for protection. Now after you prepare the exhaust and output gas ready, you can start the reaction on the system. Let system to auto checking. If any error happen, he will tell you. At the beginning, we will not start to send the temperature. We will send the gas. We can see, if you can take a record of this, we can see this one. We install 5 gas line. 1, 2, 3, 4, 5 gas line. With the 5 gas line, we can conduct quite several reactions with this reactor. Like only methane and giving, we can conduct with methane cracking. Methane cracking means you only use methane, hydrogen, and nitrogen. And with methane carbon dioxide, we can conduct dry reforming. With methane and water, we can conduct with steam reforming. And also some like glycerin reforming with mixture gas, we can also conduct. Since you replace the liquid with other kind of liquid. And also it can conduct phase transfer. Because nitrogen is the same molecular weight as carbon monoxide. So you can use carbon monoxide here and to connect reaction with hydrogen to do the phase transfer to produce carbon chain products like biofuel or high chance carbon hydrate products. So there's quite several reactions can be investigated here. It's dependent how you will apply it. So you can explore the application of the system, and you can advertise out to other researchers that them to come to rent your system to support your financial. So today I will guide you based on your dry reforming. the principle for the gas supply is first step you need to remove your residue gas either from the air or from the last reaction. So every time we charge nitrogen first. Nitrogen, because we are only use the flow, we don't care about pressure. So we go out to turn on your gas. We send it into 0.1 or 0.12, 0.15, no need to 2 more. Because we just need the flow. We can maintain it as 1 bar, means 0.1 megapascal. So when we give the nitrogen, we check 1 by 1 about the valve. Make sure every valve is closed. Like just now, you're not closed. Every valve is closed. You can see, no close. Check 1 by 1. In all the valves, vertical type, except the three-way valve is in horizontal type. Because this is closed. So double check all your valves. Make sure all the valve is closed. Then you can start to send the gas, give the gas supply, let the nitrogen go to the system. Check about the pressure meter, the first pressure meter. Make sure the pressure is enough for you to lead to the flow and lead to the reaction. Let it to go to reactor directly from straight line first. This is, you can see here, have 3 lines. This is to balance the pressure at the beginning because the reactor got kind of volume. It needs to be a little bit time to fully fill with the gas. So you lead the one to the system to fully fill with nitrogen first. Otherwise, you will got pressure different between the here and here. Pressure different is not good for mass flow controller. So before you start to use mass flow controller, you balance the pressure of the both sides of the mass flow controller, also fill the reactor first. So before you use mass flow controller, always turn on this valve first. The other line, same. Use the bottom line to balance the pressure first, then only lead to a mass flow controller. This is the first line. Then another 2 lines, one is for mass flow controller, is used for small amount, small flow. And also, when you go into pilot size, you need to bigger flow, you can use here. But when you use flow meter, the pressure you cannot conduct too high. Maximum pressure is 0.25. Otherwise, cannot afford. Because based on the optimize of your first stage investigation, normally your reaction conduct is under 0.1 megapascal, right? You are not using high pressure. Your target is conduct reaction under lower pressure. Okay? Yeah, so when you optimize into pilot scale, you can still use this one. If you use flow meter, you don't need to balance the pressure. You can directly open, and adjust the flow. This is for the function of this trade line. But normally during your investigation, you are using mass flow controller. So you balance the pressure first. At the beginning, you can fully close the system. Fully close is tight. Fully close. This one also can fully close first. Fully close the back pressure valve. Fully close when we check the valves. Back pressure valve fully closed. This one to the bubbler. Because at the beginning of the reaction, we need to check the bubble to adjust to the perfect pressure. So fully closed, go to DC, check about the bubbler. Then after we lead the gas into here, we adjust. Yeah, we open slowly and check the PI. Now you cannot have, but later we can observe. And when you adjust the back pressure valve, you check about the PI. you set it to a predict value, then you can stop. If you find the pressure here cannot reach to your setting value, for example, you want to set into 0.1, but even you fully close, it's still lower. That means your pressure outside is not giving enough, or you haven't really opened the cylinder. So if that kind of thing happen, you go out to check your gas resource. And then when the pressure is set, you can turn on your mass flow controller, double both open together, and close your balance line. At this moment, you observe your mass flow controller nitrogen. You check about it. If you cannot reach your setting value, you can slightly open bigger. If when you adjust the mass flow controller, you find your flow cannot reach to your setting value. That means here the outlet flow is too small, because the flow pass through here going out need to be enough gas can be passed through the line. If here you close too many, and it's also like a valve for your gas. Your gas cannot flow out, cannot maintain a constant, continuously flow. So the valve cannot going out. You need to give slightly bigger to the bubble. And when you give slightly bigger, if the pressure dropping down, that means no enough pressure outside. You check again. So flow, pressure, continuously bubble, these three is need to be balanced each other. So you need to practice a little bit about this. How many the gas resource pressure you need to set, how high the volume, and how big here to be open. These three balance each other, you will get a perfect result. Normally, if you are using the 0.1 megabar as the target pressure for output, you give the resource 0.15 or higher than 0.12. If too low, you will not got enough resource to let the gas flow continuously. If based on previous experience, if you give enough gas pressure at the beginning, here adjust properly, normally the flow is no problem. Can making constantly to going out. Now you have finished your adjusting for the nitrogen. This is the first step. You are charging the system with nitrogen. At this moment, as just we are discussing, you can do the washing of your gas bag. But you don't wash at the beginning, because you will charge the nitrogen for 1 hour, maybe after 20 minutes, when the fully system was charged. Yeah, otherwise the residue air inside the reactor will come to your gas bag. So you can wash your gas bag during this stage. And when the gas is setting properly, you can start to set the temperature. When you doing the dry reforming, you have two need to be set. One is the preheat. When you set 390 is enough. But you need to let it to be turned on, then only heat. Preheat temperature control. You turn on it. Then your preheat will start to work. You can see the temperature start to rise. So the first temperature you need to use is PHTC, preheat temperature control. But you need to turn on the valve. Without turn on the heating valve, the preheat will never hit.
Okay.
This is to preheat your gas, to make sure your gas has been preheated before it's mashed to a furnace. Because your furnace during reaction, you may send at 700, right? You may send at 700. If the cool gas come to directly, when it come to the catalyst, it's maybe the temperature cannot rise to 700. It will be cooled down and make the error. So we, in this system design, we will preheat the gas first. Then to make sure that the gas come to the catalyst, it already reached to 700. Because your reaction is a very high-speed reaction, attached, immediately reacted. So the gas must be prepared ready before it got contact with your system. In fact, we have two steps for preheat. First is for the preheating. Preheating furnace is fully filled with citrin. We call it citrin. Citrin is like a spring multi-surface materials. So it will increase the heating surface. Then the gas is first step preheat. And second is because your catalyst is loaded in the center of the reactor, and at the top part, it still got some space to preheat the gas. So we can make sure that when the gas is come to contact with your catalyst part, it's already heated into the target temperature. So there will be no too many different for the temperature, and make the accuracy of the reaction is really conducted under 700 degrees Celsius. This is the preheat. Then another one is the program temperature control 1, because you install your reactor in reactor 1. If you ask why there's two reactors was conducted, because initially designed for this reaction, when we conduct the steam reforming, we can do a water safety. After that, we can convert the carbon dioxide, carbon monoxide into carbon dioxide. So we can make sure the gas is fully with hydrogen and carbon dioxide. Because initially designed for using methane and steam is to produce hydrogen. So we want the gas final product is without carbon monoxide, because carbon dioxide is much easier to be removed. So after we remove the carbon dioxide, we got pure hydrogen being obtained. So after the steam reforming, we will follow giving water safety. There's two reactors. They are conducted under different temperature and with different catalysts. So, and there's two reactors was installed. But in your case, because you are doing only one reaction, so you use, now you are using temperature 1. If you are using furnace 2, if you install your catalyst in furnace 2, then send furnace 2.
But I will only focus on this one.
Yeah, if you didn't use the furnace 2, you can ignore furnace 2. You even don't need to turn on, because both furnace also control individually. So you can turn on only program temperature 1. This is the most important, is send your program. How to send your program? You can record, focus on here. Click this left key. 1, temperature 1. Temperature 1 is our starting point. We can send a room temperature, 25. Temperature 1, then click send. You got a time. Then you can see temperature 2. Then you go another is the temperature, time 2. Then temperature 2, temperature 3. Go to time 4, time 3, temperature 4, time 4, temperature 5. You go to stopping code. Now I will go to take a paper and explain this one. Okay. You collect sample from here, right? This one is a bubble indicator.
Yes.
Previously, I see students connect gas sample from here. If you want to connect gas sample from here, you cannot fill in water here. You can fill sulfur acid. why fuel sulfide acid? We can consider about our gas emitting carbon dioxide, maybe carbon monoxide, nitrogen, hydrogen. You check about whether they are reacted with the sulfuric acid or not. If not, you can fill in here with sulfuric acid that can dry the.
Or something that is inlet to the.
Yeah, it's like a drying process. But if the gas is reacted with the sulfuric acid, you cannot use because that will disturb your results. This one you must, if you use any treatment after finish the reaction, you need to be careful. For example, if your product is coming from the emitting decomposition, means the final product is meeting with carbon and hydrogen, right? So the mixture is meeting and hydrogen.
Yeah.
The product is meeting and hydrogen, and I think that time you can use sulfuric acid as the dryer. But if you bring here as water, the indicator for your reaction, you cannot collect sample from here because the gas pass through the water will carry humidity.
Oh,
The gas carry humidity is bad for the column because during the high temperature for the analyze, the water will interpret the because absorption and desorption property of your column. After too many times of the humidity charging into, it may damage
the data is not accurate.
No, it will damage your column because the one you're using is a carbon monoxide. That may be destroy the column, and some of the column even very sensitive with the water. So if you necessary, you need to remove the humidity. You can connect some purification process after this, like use for A molecule 6 to absorb the water. You can take out this.
Okay.
You can take out this. You fill in the 4A molecule 6 inside here. Put some cotton at the hole. 4A molecule 6. Silica gel, you the blue color silica gel, as an indicator. Connect to the sample pot here with this one. Then you collect your gas from here. Then you can remove the humidity when it pass through. This is much safety than you use hydroxy acid because the sulfuric acid is very dangerous, corrosive, and also it have a high oxidation. Some gas may be oxidized by the sulfuric acid. So what my recommendation is, if you notice that highly accuracy required by the influence of the humidity, you can take directly from here. If you be high requirement for the humidity, you can fill in several of the humidity absorbent inside here. Then collect gas sample from another side. Your gas will be have a little bit purified before. But no matter what kind of purified for your products, the final is the one cannot be affect your component of your gas mixture for the product because you need to be maintaining the percentage of all the gas. You just remove the humidity, but you don't affect, means some of the absorbers is reacted with one. You must be careful to use. Define whether your gas is continuous flow, is you can check from the mass flow controller.
I see.
If you note enough gas flow to support the mass flow controller, the mass flow controller will give error because it cannot reach to the set point. It will give error. So you must be pay attention either here or your mass flow controller. This is the trivial.